Alright, I'm Chris Schomburg, and I'm your instructor for AC/DC. Now, we're on the same channel, we're on the same electronics, but this time we're actually graduating from the DC signals that we've been doing in the past to an AC signal. The last lab that we just did was on the oscillator circuit, and the oscillator circuit demonstrated something new. It sounded like it was the same tone all the way through, but we actually were generating power to an AC circuit. So we're actually looking at an AC wave. So I have some more high power tools for us to kind of transition from the beginner lessons to intermediate lessons. And so now we're transitioning between using an oscilloscope, which is this on the left hand side. Oscilloscope we can see right here. Basically an oscilloscope can read AC signals, so we can actually see the sine waves, the actual waves that are actually being generated. And we'll see there's a lot more waves than just sine waves. So this is our oscilloscope. We have the channel 1. We're going to look at our oscillator in a little bit. But first we're looking at a sine wave right here. And then we're going to actually change this wave. So right now this is a function generator. And it's actually called a signal generator in this case. But it's actually really a function generator. What it can do is it can generate the wave that we see here. Later, we're going to build things that generate that wave, and actually later we're going to actually look at the oscillators that we just built and see what kind of wave it creates. So we'll start seeing waves from the things that we build in DC circuits, and really we're introducing ourselves into the AC signal. So we started off with DC signals. Now we're looking at some AC signals. So let's go ahead, let's start with this function generator. What it can do is it can change the type of wave. We can also analyze the type of wave and analyze it to a very high degree in precision. So I'm going to go ahead, I'm going to select a square wave. You can see this is now a square wave, so it kind of looks like this, like a rectangular square, instead of a pure sine wave that we saw before. I can also select a triangle wave. That is literally looks like a triangle. Okay, so that's a triangle wave. We can also select a sawtooth, and that actually has a little bit more slope to it. We'll just say it has a little bit more slope to it, and then it goes straight down, and then it has a slope to it. So that's a saw wave. Now we can do a saw wave the other way. So we see that we have a straight line, and then we have a huge slope. Straight line and huge slope. So that would be either a negative slope or a positive slope. We saw the positive slope before. We're seeing the negative slope here. Okay? And then we can generate waves that are just kind of beyond the scope of this class. Okay. So again, we can generate a sine wave, we can generate a triangular wave, we can generate a rectangular wave, we can generate sawtooth waves. It's really amazing what we can actually generate with a function generator. We just built an oscillator circuit in lab number 10, and we're going to actually look at the oscilloscope. And so if we look at it directly into the oscilloscope, the key thing that we can do is we can actually measure it. So we're going to go ahead and we're going to hook it up. We see a kind of a low signal here, which almost looks like a sine wave. And then we see a really high wave, and then we see a fall, and then we see another low signal, and then a high signal. Between here is called the period. It's a repeating signal. So we're seeing a signal that is actually repeating in this case. Now the cool thing about this is that we can actually measure it. And so there's two ways to measure it actually. One is actually to select the measure and to actually do a run stop, and then we can actually turn this off so we're not hearing the noise. But we actually can see that this is 233 Hertz. So that's actually well within a range that humans can actually hear. So let me zoom in so that you can see that. And that is right there. So we're seeing that's about 233 Hertz. Now if you were very suspicious of this, what you could do is actually you could look at our period, and earlier I measured it to be about 3.4 milliseconds. It could have been between 3.4 and 4. I measured it 2 different times. One time it was 4, one time it was 3.4. Again, what you could do is you could say, okay, I'm going to go to my calculator real quick here. Alright, so the period is just 1 over the frequency. So Okay, so we've just noticed that our period is 4.2 milliseconds. We're going to estimate and see if it's correct at 233.6 hertz. So let's go ahead and look at that. So what we would have to do is we would actually have to type in 4.28 times 10 to the y 3 negative. Okay, that's 4.28 milliseconds. Okay, so then we're going to go ahead, we're going to take that to the y 1 negative. That should give us a correct answer, and we do get the correct answer here. We get to 233.64 hertz. Okay, so they're just inverses of each other, one over the other. It's also called a reciprocal. It's called an inverse. It's called a reciprocal. Either way, it's the same math. That you just take it to the y negative 1, essentially, and that's exactly what we see. So if we look and we confirm that again, that's 233.6 hertz. So that's essentially what we actually see here. Okay, so we just calculated the hertz frequency at about 233 hertz frequency is what we actually calculated for our audible oscillator circuit. Now, I'm just curious, what kind of hearing range, what animals could actually hear that? So let's go ahead, let's look at this. So turtle would be able to actually hear that. A goldfish would be able to hear that, and that's actually one of the worst hearing animals. A frog, they say, has a range between 100 hertz, so yes, they would be able to hear that. A canary, no. A canary only goes down to 250 hertz. They would not be able to actually hear that. So they actually really hear really high frequencies. They would not be able to hear that because it's too low of a frequency for them. That's kind of interesting to me. A pigeon would be able to hear it. An elephant would be able to hear it. A chimpanzee would be able to hear that. Of course, we hear it, but we don't hear it as an alternating current. We hear it basically just as a single tone. A dog obviously could hear it. They have better hearing than we do. In fact, there are several whistles that dogs can hear that we can't because they have such a great hearing in the high frequencies. A cat would be able to hear it. A mouse would not. It says that a mouse actually would not be able to hear it because they only hear really high frequencies. So they hear between 1,000 hertz and up. So they'd actually have a huge range of hearing, but they can't actually hear the lower sounds. So they would not actually be able to hear our oscillator circuit at all, which is kind of amazing. Again, that's the same with a bat. Again, they have echolocation. They actually can hear unbelievable amounts of sounds from objects and things like that, but they would not be able to hear it because it's too low of a sound. A whale wouldn't be able to hear it because it's too low of a sound. A dolphin wouldn't be able to hear it because it's too low of a sound. However, there are animals that are related to the dolphins and whales that can actually hear between 75 hertz and 150,000 hertz. So that's amazing range, and they would be able to actually hear this. But typical dolphins would only be able to hear a range between 1,000 and 130,000 hertz. So that's pretty amazing. I think it's kind of cool. If you want to read more about this, this is a great website. This is called Hearing Range of Animals, What Animals Hear Best, and it is myihp.co.uk/animal/hearing/ranges/. And if you're interested, I will go ahead and post it. It was kind of cool to see that, not all animals would be able to hear our device that we just built. Kind of neat that we can, and it's kind of neat that there are some animals that just wouldn't be able to hear it. Even animals who have much better ranges of hearing than we do, they have a better range, but they wouldn't be able to hear it because it's so low a frequency in hertz. Okay. Well, I hope you continue to watch more of these videos and continue to learn more about science and discover more about electronics.